Good morning. Now, sorry, I've done the mistiming thing again, and I was going to give you feedback on the question you'd asked me to load you. Now, I haven't actually seen what you did for it, but I'm going to go through it anyway because it just fits into what we're doing better. But I will have a look, give you feedback for what you've done personally online. But anyway, here's a chance for you to see what you should have done, and maybe you did. I'm going to go through this question and then we'll do question 5 from yesterday, which we didn't do. So today's going to be a hybrid. It's going to be half conditional probability, and the other half we're going to look at a bit of algebra and expanding triple brackets. Anyway, more of that later. So what you should have done, we've got 3 different fruits. So we need a Venn diagram that represents that. So make sure the loops intersect each other as much as possible. So we've got apples, oranges, bananas. Doesn't matter which way round you do them, obviously. We've got 50 people all together, so they need to sit in the whole thing, and that's really important here because it does say 5 of the people do not like any fruits, so those 5 go there. 11 people like all 3 fruits, so we can put them there. 33 people liking apples, well, we've got 3 different zones to put the remaining 22 people into, so we can't do that yet. 6 people like apples and bananas, but not oranges. Well, that's useful. Apples and bananas, but not oranges. So that means we can put a 6 there. And then it says 15 people like bananas and oranges. Well, bananas and oranges, we already know 11 like them and apples, so it must be another 4 to make bananas and oranges up to 15. So that's that and that. All of the 25 people who like oranges like at least one other fruit. Well, what that means is no one likes only oranges. And 25, 11 plus 4 is 15, plus another 10 makes 25 people liking oranges. At this point, we can look here and say, right, 33 like apples altogether. We've already got 10, 21, 27 liking apples already, plus 6 makes our 33, so there'll be a 6 in there. And those that only like bananas are the only thing we haven't put in yet, so it should all add up to 50. We've already got all the apples adding up to 33, and then we've got another 4 and 5 is another 9, so 9 onto 33 is 42 altogether. So that must mean that 8 just like bananas. Work out, 2 of the people are chosen at random, work out the probability they both like bananas. Well, we're not bothered about all of these different bits, all we're bothered about how many like bananas out of how many. So out of the 50 chosen at random, so 50 is how many people we've got, and then we've got 8 plus 6 plus 11 plus 4 for how many like bananas altogether. That is 10, 18, 19, 29. I make that. So the first person that you choose would be a 29 in 50. But then the second person, and even if you do this at the same time, it still has this effect. The second person, there's only 28 others available, and out of only 49 at that point. And if you pop that into your calculator, it will give you, well, it would give you 812 over 2,450 if you're not using a scientific calculator, but if you are, it will automatically put that in its simplest form of 58 over 175. That is right, that is right. They're both just as right as each other. They're both 5 marks. Right, question 5. Pause the video and have a go at this one. Now it's up to you. There's more than one way you can do this, but I see this as a tree diagram problem myself. So we've got 7 cards and we want both numbers to have the same number. We've got 3 different outcomes that are possible, a 1, a 2 or a 3, but they can happen in different ways. There are 2 ways of a 1 out of 7 there are 2 ways out of 7 of a 2 and 3 out of 7 of a 3. Now that we take a second card, if we had taken a 1 before, there's only 1 left out of 6 cards. There'd still be 2 out of 6 left for the 2, for the 3, 3 out of 6. Running out of space a little bit here. So I've got 1 out of... oh no, I've got 2 out of 6 here this time, haven't I? Do I need to work them all out? I just want both of them having the same number on them, don't I? So let's just keep it a little bit simpler by saying it's the same number that I want. So that's this one, which is 2 over 7 times 1 over 6, which is 2 over 42. Or it is this one, and we add on the or, don't we? So to find out, there would be 1 2 left, wouldn't there, out of 6 if we've already taken a 2. So that's 2 over 7 times 1 over 6 as well. So that is 2 out of 42. And then a 3 and a 3 is going to be 3/7 times 2/7. And that's giving us 6, not sevenths, sixths, 6 out of 42. And adding those up together, we get a grand total of 10 out of 42. If you put 5 over 21, that's fine too, but you don't need to. Right, now the second problem says, calculate the probability that the number on the second card Helen takes is greater than the number on the first card she takes. Now I could do that on the diagram I've got, but I think it might be simpler just to draw the whole thing again, just thinking about whether a number is greater or not. So if I have a 1 on the first one, that's 2 out of 7. And I have got 2 ways. That is not a greater way, is it? To get a 2 would be greater, to get a 3 would be greater, and that was 2 over 6, and this one was 3 over 6. So for these two, I've got 2/7 times 2/6, which is 4/24, 4/42, and I've got 2/7 times 3/6, which is 6 over 42. Then if I've got a 2, a 1 is not, a 2 is not, a 3 is greater, so that is going to be 2 over 7, and this one will be 3 over 6 again. So that's another 2/7 times 3 over 6, which is 6 over 42. And if I get a 3, all 3 roots are not greater than the number on the first card. So it's just these 3. 4 add 6 is 16 out of 42. And again, if you got 8 over 21 or turned it into a decimal, that's okay, but unnecessary. Right, that's it for conditional probability. We will now move on to having a little bit of fun practicing expanding brackets. Right, now we won't get through all of the questions on here today, so any that we don't, I put the answer scheme out there as well so that you can have a go at them. You might want to practice this in a couple of weeks' time or something, just put it to one side, on part of your revision schedule or something like that. Anyway, now there's 2 ways of doing this. You can do it all using the grid. I will do the grid one time, but I'm going to stress trying to expand just the pair of brackets using the sum and product method. So when you've got x and x there, you know x times x will be x squared. Then the number of x's you get will be the sum of these two numbers. 2 plus 4 is 6, so it'll be 6x. And then you'll get the product of 2 times 4, giving you 8. And then that is going to have to be multiplied by x plus 1. Just in case you weren't happy with the sum and product method, I'm going to write it in there, but I'm also just going to very quickly draw you the grid here. Now I'm not going to do this on all of the others. I'm just going to do it for the second part until things get trickier with coefficients. So x times x is x squared, 2 times x is 2x, 4 times x is 4x, 2 times 4 is 8. And then we can put a peanut here when we simplify and add the 2x to the 4x, which is why we get the sum of those two numbers as our coefficient of x. Now that we've got this, all of this bracket needs to be multiplied by that one. So we're going to do the same idea again. I normally like to put the 3 terms along the side, it just makes it a little clearer. X squared, 6x and 8. And they're going to be multiplied by x and 1. So x times x squared is x cubed, x times 6x is 6x squared, and x times 8 is 8x. Then times everything by 1 just gives you x squared, 6x and 8. And then we've got 2 peanuts to go. We've got our x squareds and we've got our x's. That's going to give us a final answer of x cubed plus x squared plus 6x squared is 7x squared. 6 add 8 is 14, so 14x and plus 8 on the end. So here's question 2. Pause the video, give it a go. So I'm going to begin by doing, I've got negatives and positives, haven't I? So let's just be careful. So I know I'm going to have x squared. Negative 3 plus 5 is plus 2, isn't it? So that'll give me plus 2x. Negative 3 times 5 is negative 15. And that has got to be multiplied by x. I don't know why I wrote 12 there, x minus 2. So then we have x squared plus 2x negative 15. And we've got x and negative 2. Multiply through there, x cubed, 2x times x is 2x squared, minus 15x, times everything by negative 2. Just be careful when you've got a negative times a negative, that's plus 30. And then we've got to be careful again, adding our negatives together. So you've got x cubed, plus 2 take 2 is nothing. Negative 15 add negative 4, well that's going to make more negatives, so that's negative 19x and plus 30 on the end. Okay, I'm going to leave questions 3 and 4 for your own independent practice and have a go at this one. Now we've got x plus 3 times x take 1 squared. Now, it doesn't really matter which one you decide to do first, but remember this means x plus 3 times x take 1 times x take 1. I think I'm just going to do, let's do the take 1 squared one. X times x is x squared. Negative 1 plus negative 1 is negative 2x. Negative times a negative is positive, so plus 1 at the end. And then we're doing the same idea. And we get x cubed, take 2x squared and plus x. And multiply all along the bottom there. And what have I done strange there? I haven't got a squared in there, have I? So then we need to peanut the x squareds and the x's. Be really careful to make sure you don't cover up your negatives. So we've got x cubed. We've got 1x squared, we've got negative 5x and plus 3. Here's question 6. Pause the video and give it a go. It does bring in a new issue for us. I'm starting off by just doing the same thing here as I would do. I'm saying sum of 5 and negative 3 is plus 2, so that'll be plus 2x. 5 times 3 is 15, so that's negative 15. That's going to need to be multiplied by 2x take 1. So then I'm drawing out my grid. And as soon as you get coefficients in here, I never try to do these in my head. I've been burnt too many times trying to be clever. It's just that little bit too much for my old brain. So, and also it does make sure that you're showing your process marks in the exam. So you really do need to do this. There are 3 marks here, and they might take one off if they just see the answer. 2x times x is 2x cubed. 2x times 2x, well, the number times the number is 4, the x times the x is x squared. 2 15s are 30, so negative 30x. Timesing everything by minus 1 is just going to change the polarity. There's our x squareds and there's our x's. So I'm finishing off with 2x cubed. 4 take 1 is 3, so plus 3x squared. 30 add 2 is 32, so negative 30 add negative 2 is negative 32x, and plus 15. As we haven't got that much time left, we're going to do questions 11 and 12, and then I'm going to leave you to sort of get on and do as many of the other questions as you like. So this is the sort of place that it can get to, where they ask you for a show that, which just means you've got to demonstrate that you know what the stages are in between. So pause the video, give it a go. So I'm going to start off by expanding 2x plus 3 and 5x plus 2. It might be slightly simpler to use the x minus 5 at the beginning, and if you did that, it's not a problem, as long as you get to the right place in the end. So 5x times 2x is 10x squared. 3 times 5x is 15x, x squared because x times x, and 2 times 5. 2 2's are 4x, 2 3's are 6. So then all we need to do is say that that means what we've got is 10x squared plus 19x plus 6 in a bracket that just needs to be multiplied by the third bracket. And then write out another grid for that, 10x squared, 19x plus 6, and you've got your x and your negative 5. Multiply them out, gives you 10x cubed, 19x squared, and 6x. 5 tens are 50, so negative 50x squared. 10 times, that would be 190. Half of that is 95, so minus 95x and negative 30. Then we just need to peanut those, and we've got 10x cubed. 50 take 19 is 31, so it is negative 31x squared, minus 89x take 30. Double check at this point, 10x cubed, yes. Negative 31x squared, yes. Negative 89x and negative 30. So we're all happy with that. And if you want to be really fancy, you can write as required at the end. Not sure why they like that, but they love it. Okay, one last go. I'm going to just pause the video and give it a go. You should have started off with, and if you wanted to do 3x plus 2 times 3x plus 2, do that one first. That would be absolutely fine. I've done it this way. 6x squared, 4x minus 3x, negative 2. Add those together is going to give you 6x squared plus 1x, take 2, multiplied by the 3x plus 2. 6x squared, x, negative 2, 3x and 2. Take your time. Now this should give us what we've got over there. 3 6's are 18, x cubed, 3x's times x is 3x squared minus 6x, 12x squared, 2 times x is 2x, and negative 4 there. and they add up to make 15x squared, which is what we want. 2 take 6 is negative 4x, which is what we want, and negative 4. So we are done. Right, so I hope you all managed to get out and enjoy the sun today. Actually, I hope you did that yesterday for you, isn't it? Because it's probably raining today. So if you do find yourself having to stay in, do a few more of these questions. All right, folks, see you soon. Cheerio.